We're going to continue on with our discussion of completion stage methods, just the overview, introducing what they are. This is part 2 of that discussion, and we're going to talk about some benefits of using completion stage methods, and one of the main benefits is they avoid blocking the calling thread. So we'll see how that's going to work. So the purpose, one of the purposes, there's several purposes, but one of the purposes of completion stage methods is to minimize and/or avoid blocking the calling thread. And the reason for doing this is to try to improve responsiveness by not blocking the caller. Remember, that's one of the reactive programming principles, is to be responsive. And if you block the caller, you will be less responsive. Why is that? Blocking can impede the inherent parallelism that's available, especially on modern multi-core platforms, by underutilizing the processor cores. And arguably, it may also complicate program structure depending on other things that you might do. And there's a nice little article that talks about why you can have problems with blocking code. So you don't want things to block. Another thing to remember, and certainly remember this when you do the programming assignment. I think I have a comment in the assignment, and I talk about it in the walkthrough video. Please try to avoid calling join or get unless absolutely necessary. My general rule of thumb is I try to avoid it. Sometimes you have to do it because you need the result back before you can do something like print the results, where the program is going to exit. But try to have just one call if you possibly can. And sometimes you don't need any calls at all, especially if you're doing server-side programming. Sometimes on the client side, you need to join. Try not to use get either, but you need to join because otherwise you'll run off the end of the client, which is not going to be good because then your program will shut down. But you can usually figure this out when you look at the code. Clients can often avoid blocking until a result must be obtained. And we're going to take a look at an image counter program example later, probably after the program is due, because it kind of shows things that are related to what your program does. But this is something to be aware of, and we'll take a look at how to do this. This does a similar idea of traversing through a recursive folder structure, counting the number of images that are there. So it's a little different from your program. Another theme here is user interfaces, especially the user interface thread, shouldn't need to block in order to ensure responsiveness. And one of the nice things about reactive programming is it's been baked into programming environments like Android. There's a thing called RX Android where you can use reactive programming in the context of Android. And it's pretty cool. Although, if you know much about Android, you know a lot of the user interface code is moving towards Kotlin these days, but there's undoubtedly something similar you can use there as well. Servers may be able to avoid blocking altogether. And we will talk about this a little bit in the last session of the class. But for right now, just to give you an overview of what's coming, the idea is that on the server side, you often don't have to block. You just let things run to completion, and when they're finished, they send a result back to the client through some kind of HTTP response. And the nice thing about doing this is you can decouple request reception, processing, and response, and you have a very small number of threads, typically as many threads as there are processor cores, as opposed to what you used to have to do where you'd spawn lots and lots of threads in a pool of threads, which would then either be too many or too few, depending on the circumstances in which you were deploying your server. So this cleans things up a lot. And we'll talk a bit more about that in the reactive programming part of this course, and a lot more about that next semester in my other course. So that's the end of the overview of Java completion stage methods part 2.